Dang it. I keep forgetting I can't whistle with this thing on. It's so annoying because I really want to whistle to that track. Oh, well. All right. Good afternoon, everybody. I think everybody. Oh, somebody just joined it. Oh, Brian got here just in the nick of time. Still no Wendy, though. Okay. Words of wisdom for today. Remember this. Victorious warriors win first, then go to war, while defeated warriors go to war and then seek to win. Okay, the difference, the preparation, and the planning, the attitude, right? That is what will lead you to victory. So with that in mind, our plan for today involves surface area. Finding how much paint is required to paint the room, right? Very, very common word problem of this sort. And surface area, while the SAT would love to try to make it seem more difficult and complicated than it really is, it's just area. Surface area begins with area. All it is finding the area of multiple shapes. It's a sneaky way of fitting in multiple smaller questions into one large question. And so if you know the basic area formulas, you're set. You're fine. It's just stacking those on top of each other. That's all it really is for surface area. Now, of course, the basic area formulas, as I'm showing right here, these guys, this is given to you. This is provided on the SAT itself at the beginning of every math section. They will give you this exact reference document. All of these formulas are given. You do not need to remember them yourself. No need to memorize. This is provided. I will provide this on my own test. And in fact, you're allowed to use your notes, which should already have these, at least the area and volume ones. We'll get to these guys next week. Those should be in your notes, so you could look those up there as well. Okay? So there's no excuse for not knowing these. There's no excuse for messing up this part of it. You have those, and you've been using these formulas since, like, what, third grade? Right? Depending on your school, I've looked. It's a very common starting point for a lot of curriculum to start with area, okay, in third grade. And so really by this point, you should be as familiar with these enough that you remember them by happenstance. It's not that you tried to memorize them, you're just so familiar with the area of rectangles and triangles and maybe circles if we're lucky, that they should just come naturally. So do you need to memorize them for any tests or anything going forward? No. Should you memorize them anyways just to save yourself the time? Yes. Okay? Anytime you have to stop, go back, flip, 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 look something up, oh, that's what it is, flip, 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 okay, write that down over here, that wastes time. Okay? And on the SAT, time is of the essence. So if you can really push yourself and say, hey, brain, I really want to remember these formulas and memorize them so I don't have to look it up every time, do that. It will benefit you in the future, but it's not required. Okay? Now, that said, when it comes to surface area, it's just stacking these on top of each other. The trick then to a surface area question is knowing, okay, this three-dimensional object, here's one, is made up of which two-dimensional shapes. So I know which formulas to use and where and how often, right? So that's all the breakdown. Once you do that step, now it's just go down your list, find the area of each thing, and then add it all up at the end. Okay? So let's review some of our three-dimensional shapes. We kind of defined these in the beginning as being composed of different shapes there. So we did this breakdown once. Let's review it again. Every prism is made up of two matching polygons and a whole bunch of, anyone? Type it in chat if you know it. You got the two matching bases, and they're all connected by what? What kind of shape is that? A prism has two matching bases on the ends, and they are connected by what? What's the other shape that makes all the prisms? It is rectangles. Right? Okay, well, okay, Leslie, yes, technically you are correct. Those shapes then are composed of lines, but the lines do not, you cannot find the area of a line all by itself. Now, pyramid, similarly, as we said, has the one polygon base on the bottom. And then instead of rectangles, it's a whole bunch of triangles. She's got it. Right. Oh, Leslie's got it typed in too. Yeah, so we're talking about, okay, find the area of the base here. In this case, this would be a square. Find the area of this triangle plus this triangle. Right, so you got to analyze this, break it down, 4 triangles plus 1 square, right? That's all there is to it. Cylinder is a little bit trickier. Cylinder, you have the 2 circles, top and bottom, or end to end, right? But then what goes around, remember soup can label. You peel that piece of paper off, you end up with a rectangle. But here's the catch. The height of the rectangle is the height of your cylinder, and then you unpeel that, and the length then is the distance around one of the circles. So the length of that rectangle comes from the circumference of the circles. So you actually need both of these formulas, the area and the circumference formula for the circle, in order to find the surface area of a whole cylinder. A little bit more involved thought-wise there. All right, any questions at this point then? No? Okay. So today's practice is pretty straightforward. Okay, use those formulas, find the surface areas of these things. Cones have their own special formula for the lateral side there. That should be in your notes. You can check that. Same with trapezoids. Look down here, number 7. This is a trapezoid face there. Should have a formula for trapezoids. I know it's not on your reference provided here, but it should be in your notes. I want to draw your attention, though, to number 5. This is a good example of watching out for what is given and what numbers you actually need, okay? Because it'd be very easy for them to have given you the height of the pyramid from that center and the base on the inside up to the tippy top. They could give you that height. Take a look at this, my 3D model here. Okay, I think let me switch to the zoom in. Yeah, so you can see a little better. Okay, the height would be the distance between my hands. Right, from the very bottom straight up, right? I need to go vertical and perpendicular from that to the tip, right? It is not the same as the slant along the edge here, right? The height is different. So be careful what they give you. If they give you the height, you can't use that number in calculating the surface area. Because for the surface area, I need to find area of a triangle. And to find the area of the triangle, I need its height, which is straight up and down. It's got to be perpendicular to this base. If they give me the edge here, that does me no good. That's not the height of the triangle. Back to the diagram. I've got a triangle face over here, which I'll highlight there in blue, that they do give us, right? Length L. Let me redraw that triangle over here. Right? It's an isosceles triangle. Those are matching sides, and they give us L. And it's perpendicular. Okay, that's the important part. The height of your triangle must be perpendicular to your base. In this case, the height of the triangle is actually length L, probably for lateral height of the pyramid. And then the base here is right there on my shape, and it's a regular hexagon. So this side, the same as that side, the same as that side. These are all S's. So the base of my triangle is actually S. It doesn't matter what letter they give it. The important thing is to know where to grab the number from the given. Right? So again, watch out. If they gave you that slant height, that would do you no good. You couldn't use that number. You'd have to actually, in this case, use a bit of trigonometric tricks to figure out what the lateral height would have to be. But after you do that, hey, there's triangle. It's a hexagon. So we find the one hexagonal base plus the 6 triangles, add it all up, and there's my total surface area, right? Pretty straightforward. Nothing to it. Easy peasy. Agreed? Well, you guys are good if you do. I think that that's pretty easy there, because that's not so easy. I lied. That's a tricky one. What's wrong with the base of this pyramid? It's a hexagon. I don't got a formula for hexagon down here. No hexagon. How the heck are we supposed to find the area of a hexagon? I don't think that was in your notes. That's not a common one. It's not like trapezoid, where it's like, okay, it's not on there, but it's like the next most common quadrilateral. No. We need a way to find the area of a regular polygon. Luckily, regular polygons can also be broken down into a simpler shape, just like prisms and pyramids. What shape would that be? What could I chop my hexagon into? It would be really easy to find the area for. What do you think? Remember, you want to simplify it. Make it as simple as possible. Don't cut your hexagon into smaller hexagons. That doesn't help the problem, right? Draw a picture. Draw a quick hexagon. Can I cut that into squares? Will that fit evenly? Rectangles? No. What could we cut it into? They would fill it completely, so we could find the area of these smaller, simpler shapes, add them all up to get the area of my hexagon. Something that we do know the formula of. What do we got? Take a guess. We've done it before. When we were finding the interior angles. Remember that drawing? To find the interior angles, I divided the shape up into other shapes that we knew the interior angles of already. What was that? Why are you scared to make a guess? You did so well with the prisms and pyramids up here, guys. A rhombus? Ooh, rhombus would be pretty good. You actually could do a lot with rhombuses. That's not a bad idea. Let's go simpler than that, though. Every rhombus can be divided into two whats? Triangles, right? Can you divide a triangle up even further? If you cut a triangle in half, what do you get? 2 triangles, right? So like triangle is the simplest possible shape. It's the fewest number of sides that still makes a closed figure. Okay? So every polygon can be reduced. In fact, everything can be made up of triangles. That's how three-dimensional computer graphics works. Everything is made of triangles. So when in doubt, reduce to triangles. Okay, just take that and apply it. You can use that all year, every time. When in doubt, reduce to triangles. It will work. It's not always the best, fastest, easiest method, but it will always work. Except perhaps in the case of circles. Okay, we're dealing with straight sides here. Now, how does that help us? Well, you have to draw the triangles just right. Because if I draw my triangles like I did with the interior angles, if I did something like this, here's my pentagon, I've got 3 triangles. I don't know the measures of these things. I have no idea how long that line is or what the height of this triangle is. That style does me no good. So instead, what I'm going to do is go from the center to each vertex and slice these guys up like a pie. Okay? Cut up your regular polygon into pie slices. And not only is it delicious, but it gives us now equal triangles. So what was the area of a pentagon, let's go sub 5, because a pentagon has 5 sides, right? Is now just 5 times the area of a triangle, right? Because they all have this same base. It's a regular pentagon. This is, right, what do they tell us, 3 inches? So that's 3 inches, that's 3 inches, that's 3 all the way around. They have the same base. This length, because it's the center, it's by definition going to be the equal distant to all the vertices, so all the sides are the same. All these triangles are exactly the same. Okay? This makes it way easier. Just 5 times the area of a triangle. And I know the area of a triangle. That's going to be 5 times 1/2 base times height. And in this case, let's use this one for example. My base here is 3. Oops, why did I write equals again? Times 1/2. So that's more generally the side length, right? Times the height. Ooh, what's the height? Well, it's not the blue lines, I'll tell you that. What I drew here is not the height of the triangle, and we can tell that. You know, if I had to draw in the height of this triangle, what I would want to draw is something from the tip down to perpendicular to the base I've already established, that 3-inch mark. And it turns out that is exactly, by definition, the apothem. Somebody way back thought, hey, this would be so useful, let's give it a name. This is possibly a new word, should be in your notes from this weekend. The apothem is a segment going from the center perpendicular to the side of the polygon. So I could draw it anywhere in here, and thus it exactly meets my needs for the height of my triangle. Which means in this case, they tell us it was 2.1 inches. So the area of my pentagon now is 5 times 1/2 times 3 times 2.1, which is, carry the 1, 31.5 divided by 2. Okay. 15.75. Don't believe me? Double check with your calculator. And then, of course, units, inches squared, because we're dealing with area. Not too shabby, right? So as long as they give you the side length and the apothem, you're set. You can just break the thing into triangles and you can find your area of your polygon that way. Tried and true, never fails. And you could be done there. That will work. You can stop. If you want to just take that, go on to the rest of the worksheet. I won't hold it against you. But some people really like their formulas. Say, hey, wouldn't it be great if we had an even more specific general formula for any polygon? And the answer is absolutely. We can do this. And you can use it, you can memorize it if you want to. Totally optional. Here's what we're going to do. First, I'm going to replace base and height with my side length and my apothem. And of course, we want the general formula. So let me scoot this over a little more. Not just a pentagon, but any n-sided polygon. So it's going to be n sides times 1/2 side length times apothem. And that would be pretty good. We could also use that and stop right there. But we can go one step further because check this out. In my pentagon, I have 5 sides, all of length 3. 1, 2, 3, 4, 5. So if I take 5 times the side length, I've gone all the way around, haven't I? We've got a name for that too. That's called the perimeter. So I could rewrite this, the area, it's a terrible A, of any n-sided regular polygon is 1/2 the apothem times the perimeter. Now we're getting fancy with it, right? And I think there was an example in your notes this weekend that actually did use that formula. So there you go. Now you know where it comes from. That's not true yet. But remember, break it up into triangles will always work. So if you don't want to memorize this, just understand the process of how we got there and you'll be fine. Any questions there? Okay, seeing none, then I leave you with this final thought. On these exercises, let's say I mentioned 3, you've got formula for cone. 7, you've got formula for trapezoid. Oh, number 8. I'll make one final comment there. Watch out for the holes in things. If there's anything the SAT loves to do the most, it's make things more complicated, right? So they took a perfectly good surface area question. We're going to make it more complicated by cutting a hole inside of an object. So not only do you have to find the surface area of this cylinder, but there's a catch. The top of this cylinder is not a solid circle, right? The top of the cylinder is a circle with a square hole in it. So I need the area of circle minus square, right? If you were to paint this object, you're not going to paint that square. It doesn't exist. It's not solid. Okay? So don't accidentally count that square. But if this was a real physical object and I want to paint every surface, outside and inside, I got to get down inside that hole, and I would be painting, whoops, it moved on me, the rectangular faces inside. Those are going to get covered, so you do have to add those. Okay, so that's how they make it tricksy on us, is they renegotiate what pieces you actually have to add and what pieces you should subtract. Don't let that throw you off. And now with that, then, I think I'm done for the day. You have till 20 minutes exactly to work. I will leave you to it.